Welcome and hello to this EU Datathon 2022 webinar. This webinar will focus on Challenge 1, a European Green Deal. And as you know, there are lots of data sets out there about climate, about ecology, and so on. But where to find them and how to use them, that's something we will learn today. And we are very happy to have the European Environment Agency with us. And with that, I give the floor to Anna.
Thank you, Simon. Good afternoon, everybody. As Simon said, I work for the European Environment Agency, and I'm working in the team that is in charge of the implementation of the Copernicus land monitoring service. And from now on, I will be using the acronym CLMS when referring to the service. So CLMS provides operational products. So we have a time series. They are regularly updated, derived from satellite imagery and produced by the remote sensing industry. Products and services are made available free and open, which is the data policy of Copernicus, and they are made available through the Copernicus Line portal, both as view and web map services and also for download. We are now moving more into the direction of putting our data in the WikiODS platform. Some products are already there, but not all of them. Now, within the full portfolio of CLMS, there is a group of products that we refer to as priority area monitoring. And in that particular group of products, we have Urban Atlas, riparian zones, Natura 2000 sites, and coastal zones. These are vector-based, very high-resolution land cover and use mapping products in priority areas. And those priority areas are those that I just referred. Urban areas, riparian zones, Natura 2000 sites, and coastal zones. They don't cover the full territory, but they cover these priority areas. They have a minimum mapping unit between 1/4 of an hectare and 1 hectare. They have a tailored nomenclature and a 6-year update cycle so far. The data is extracted from very high resolution satellite imagery, typically between 1.5 and 4 meter resolution. Now, I will concentrate on the Urban Atlas suite of products. And the first product that I will show you is the land cover land use product. The area covered is approximately 1.3 million square kilometers, which is a lot. As you can see depicted in the illustration on the right side of the slide. And the red polygons that you see there are the functional urban areas. And a bit later, I will explain what functional urban area is. Reference years we have so far is 2006, 12, and 18, with a variable number of functional urban areas covered. We cover also EU 27, the UK, EFTA countries such as Iceland, Norway, and Switzerland, plus the West Balkans and Turkey. And this extended area is because EA also works with other countries besides those in the EU area. Each polygon of this dataset contains what we call harmonized land cover land use information. And it's harmonized because it applies the classification with 27 classes. There's different minimum mapping units. We have 1/4 of an hectare for the artificial classes and 1 hectare for the rural classes. I will explain a bit later which classes am I talking about. Total of 27. But first, I will start by explaining and illustrating what is a functional urban area, so that you have a better understanding of what is the unit that we are mapping. And after that, I will give you a few details about the nomenclature. So, what is a functional urban area? It's composed of the city and its commuting zone. That's the definition. And it can be defined in 4 steps. You have them depicted here in the slide from left to right. The first step is to identify an urban center. An urban center is a set of contiguous, high-density grid cells with a population of 50,000 inhabitants in the contiguous cells. A high-density cell is the cell that has more than 1,500 residents per square kilometer. The second step is to identify a city, which is one or more local units, so more administrative units that have at least 50% of their residents inside an urban center. Then we move to identifying the commuting zone, which is a zone of contiguous local units that have at least 15% of their employed residents working in the city. Then we finally reach the functional urban area, which is the combination of the city with its commuting zone that you can see here on the right-hand side. So in a way, we can say that the functional urban area encompasses the economic and the functional extent of cities based on population density and people's daily movements. Now, moving to the nomenclature. And as I mentioned before, there is a total of 27 classes. And at the most aggregated level, we have the artificial classes, which are the most important ones for this product. They are the more detailed, and that you can see here inside the red box. And then we have the blue box, where the agricultural classes, natural and semi-natural areas, wetlands, and water feature. And here you can see that the minimum mapping unit that I referred before is different. In the artificial services, so all classes that start with 1, the minimum mapping unit is 1/4 of an hectare. So a lot of detail in the core city areas. And then we have 1 hectare of minimum mapping unit in the other classes. I will give you now an illustration of the product in an area in Milan, Italy. This is the city. With this illustration, I want to give you a taste of the level of detail that the product offers. Now, what does the data show? Here in this slide, I want to illustrate how do what we call the status layers and the change layers look like. A status layer shows what is the land cover at a certain reference year, and the change layer illustrates what has changed in a certain period. So we have here 2006, 2012, and 18 the status layers, and 612 the change layer, 1218 another change layer. And as you can see, this has been a very dynamic area. This is around Montpellier in France, and there's a lot of construction or changes, but also expansion of the urban area that has been happening. So in a nutshell, this data layer can give you a good insight into urban dynamics. We are now preparing for the 2021 reference year that by reducing the update cycle from 6 to 3 years. Now, we have a few more additional products that are also part of the Urban Atlas suite of products. The first one is the street tree layer. You can see here an image. And for this product, we have data from 2012 and 2018. Be reminded that 2012 only offers partial coverage. We had troubles with the input satellite imagery that in certain areas was not suited to detect trees. So it's only a partial coverage that we can offer in 2012. The 2018 is much better quality. So street tree layer is an additional layer of information that is produced within the level 1 urban mask, so the most detailed of the classification. And it includes contiguous rows or patches of trees covering more than 500 square meters. And they have also a minimum mapping unit, width of 10 meters. There's a second product, which is the building height product. It is composed of a regular grid of 10 by 10 meters containing the height of building blocks. And this one, as the street tree layer, is also produced within the level 1 urban mask. At the moment, in our website, we only have for dissemination the capital cities, but we have now finished the production with a company with whom we had a contract for all of, as well for 2012, for all cities across Europe. So we will have all cities within the 788 functional urban areas. In the next 2 months, I hope to be able to put them in the website for dissemination. One next product is the population estimates per urban atlas polygon. On the left side, you can see the urban atlas polygons in an area in France. And here on the right side, you can see the same polygons, but this time with population density, also a piece of information inside the polygon. So this kind of product opens up new possibilities for additional analysis angles that you might want to do that link land with population. So we have here kind of a fusion of land cover land use with socio-economic information. This data set can give you a better idea of the spatial distribution of population than what you can get from a regular population grid. The population distribution is now in the polygons. So in the future, if we include building height information in this estimation, we will be even closer to reality. Now I'm moving on to show you some examples of the use of urban atlas data and hoping to inspire you for your future challenges. I'm starting with the work in support of the nature restoration law on urban ecosystems that the agency has created, for which the agency has created a series of dashboards that are derived from urban atlas. The first three that I highlighted in the first polygon here, red one, refers to land take in functional urban areas, in urban floodplains, and in urban protected areas. The land take indicator addresses changes in the areas of agriculture, forest, or other semi-natural lands that are taken over for urban or other artificial land developments, therefore the name land take. We have two more dashboards, the urban green infrastructure that uses the green urban areas class, the urban atlas and the street relay, and we also offer the urban tree cover. There's the last one, which I also show here because it shows information on within the functional urban areas, which is the land use efficiency. And I am just listing them here so you can have examples of how the data is being used and how it can be combined. But talking about combination, you can also combine it with other CLMS datasets in order to achieve a more complete picture of the landscape. The example that I will show you here is the overlay of urban atlas with riparian zones, which is complementary to the urban atlas, but contains more detail in the riparian zone classes, while urban atlas contains more detail in the urban classes. And we can also overlay it with imperviousness density. And then you can extract all kinds of conclusions from, if you do analysis with these three data layers. This is just one example of combination of CLMS data. Now, if we think about green urban areas in cities, we know that they can fulfill a variety of functions, from ecological functions, recreational functions, to promoting health or enhancing quality of life. DG Regional and Urban Policy developed indicators on access to green urban areas for the population of cities in Europe. And the method uses urban atlas polygons to determine an area of easy walking distance around an inhabited urban atlas polygon. And then they calculate the median surface of green areas that can be reached in this time. And this time is around a 10-minute walking time. So how much green can you reach in a 10 minutes walking time? And the result of this study was a publication by DG Regio called A Walk to the Park, interrogation mark. So I'll leave you here with some illustrations and the link in case someone is interested to find out the use of Urban Atlas to assess access to green urban areas. This in the proximity indicator can also open up opportunities for analysis by combining it with the distribution of demographic, socioeconomic, other environmental variables in urban areas. Those can be population by age category, household income, unemployment rate, local air quality, exposure to noise, etc. There's a myriad of other variables that can be combined. Now, one other example is the use of Urban Atlas is the derivation of local climate zones. And this classification system, the local climate zones, distinguishes 17 different classes divided by delta types, as you can see on the left side in the image: compact, open, low-rise, mid-rise, etc. And the one on the right side, land cover types: dense trees, scattered trees, water, bare soil, etc. And we can derive local climate zones by combining several CLMS datasets: the Urban Atlas on cover land use, the street tree layer, building block height, and imperviousness. We did this for five functional urban areas, not for the whole 788, but we did. The agency, did a trial. These local climate zones can be used to detect urbanitarian effects in cities and to determine, for instance, whether similar zones experience similar intensity or magnitude of urbanitarians. Of course, you also need temperature measurements here and there, but you might, with this information, you might decide where best to measure the temperatures. And I'll show you an example, which is the city where I come from in Lisbon. This is the result of the derivation of local climate zones on the basis of Urban Atlas for the city of Lisbon. And one last suggestion that I found out just now that it matches the challenge that is identified for this data set, which is the European Green Deal. I show it here as a possible area to explore. I suppose you know, the Green Deal aims at improving the well-being and the health of citizens by providing, among others, and I say among others because there's a whole myriad of areas of initiative for the European Green Deal. But one of them is the aim to have renovated and energy efficient buildings. This is known as the Renovation Wave, aiming at the better energy performance of buildings. Maybe Urban Atlas, together with the other sources, can have a role to support efficient building and renovating. Well, we should not forget that by 2050, 70% of the world's population will be living in cities, 50% of which not yet built. Of course, this is happening mostly not outside Europe, but still, in Europe, we have seen an increase of 7.1% of artificial service from 2000 to 2018. And I'll give you a last slide with a summary, and my vision for this data set. The Urban Atlas provides harmonized time series of data throughout Europe that allows comparison among cities and regions. For instance, in certain areas when no better data is available, it can be used for planning purposes, for estimating various indicators if combined with other data sets. For instance, by comparing percentages of land use classes, a planner can develop a macro image of the form of its city. It can also be used for monitoring growth, as I showed before with the Montpellier example, and for instance, estimating the impact of various policies such as climate change adaptation in urban areas, for instance. So I hope that further research in the area of the definition of urban metrics might be stimulated by the availability of such a massive data set for covering almost all cities in Europe. And cities are very important places. It's where most of the population is where most of the investment is. So they need special care. And I'll leave you with my last slide and my wishing you all the best of luck for your future challenges. Thank you.
Great. Thanks so much, Anna, for this presentation. And I guess a lot of participants will use this data set in one way or another as a source for various apps, because a lot of things can be built on top of it, which I think is great. And it's very deep in knowledge in the data set. So thanks again. And for those of you who are interested, we have next week another webinar with the European Central Bank. See you. Thanks for joining.
Thank you.